Okay, let's talk about NS3. If you're in the world of network research, you definitely know this tool. It's legendary for being incredibly powerful, but, well, it also has a reputation for being just ridiculously hard to learn. So why is that? Why is this essential piece of software so confusing for so many people? Well, that's exactly what we're going to dig into. We're going to look at this from both sides, from a user who struggled with it for over a decade, and from the actual core developers who built the thing. Let's see if we can solve this puzzle. All right, section 1, the NS3 puzzle. And it really is a puzzle, isn't it? On one hand, you almost can't do serious, cutting-edge network simulation without it. But on the other hand, it drives people crazy, even folks who are totally comfortable with its older brother, NS2. Okay, section 2, simulator or library. And honestly, this right here, this is the whole game. It gets to the heart of a misunderstanding so deep that it apparently took one user 10 whole years to figure out. It all boils down to one simple question. What is NS3? And here it is, the big aha moment. See, the whole way of thinking shifted between NS2 and NS3. The best way to think about it is with a car analogy. NS2, that was a ready-to-drive car. You just gave it a script, like telling it an address, and boom, it went. NS3? Whoa, totally different. It's not the car. It's a high-performance engine kit. It's the engine, the transmission, all the best parts, but you have to build the car. So let that sink in for a second. There is no ns3.exe. There's no single program called NS3 Simulator that you just run. It doesn't exist. Every single time you write one of those C++ simulation scripts, you're actually creating your own brand new, totally custom simulator. Your code, the one with the main function, that's the simulator. You're not using a tool, you're building one. And you can just feel the pain in this quote from a veteran user, right? I wasn't able to find one such simulator for 10 years. 10 years. He was looking for a program that just wasn't there. It's this fundamental identity crisis that causes so much grief right at the beginning. People are hunting for an application to run, but they're supposed to be using a library to build. Okay, section 3, freedom versus standardization. So now that we get that NS3 is a library, not a program, let's see how that philosophy plays out. And there's no better place to look than at how you get your results. You know, the whole point of running a simulation in the first place. So the simulation's done. Now what? How do you actually analyze the results? Back in the NS2 days, this was easy. There was one way to do it, a universal trace file. Simple, one size fits all. But with NS3, oh boy, you have options. A lot of options. And that's where things get complicated. And I mean, just look at this list. ASCII tracing, PCAP tracing so you can use Wireshark, flow monitor, custom tracing, SQLite, the list just goes on. It's this incredible buffet of data extraction methods. You can tap into literally any event at any layer of the network stack. For a researcher, that's an insane amount of freedom to get precisely the data you want. But, and this is a big but, all that freedom has a price. And that price is standardization, or the lack of it. Because there's no single universal format. A simulation for, say, LoRaWAN might spit out its data in a completely different structure than a simulation for NB-IoT. So now you have two piles of results, and trying to compare them, it's not apples to apples anymore. It's apples to something else entirely. And that's a huge headache for reproducibility in research. And this is where we see the two worldviews collide. One of the core developers, Tom Henderson, says, "We have felt that the non-standards was a feature, not an obstacle." And that just says it all, doesn't it? To them, this isn't a bug, it's a feature. The whole point is to give you the freedom to do custom, super specific analysis for whatever crazy scenario you're cooking up, not to box you into a one-size-fits-all. All right, section 4, code for experts. This brings us right down to the nitty-gritty, the code itself. Is NS3 just naturally complex because it's so powerful? Or is it maybe a little too complex, creating a wall that keeps people out? So take a look at a typical line of NS3 code. Now, you don't have to be a C++ wizard to see that this is a lot, but there's a reason for it. This approach is what you might call machine-friendly. It's incredibly precise and leaves zero room for ambiguity. It's using some pretty advanced C++ features to set one default value that applies everywhere in the simulation. Powerful? Absolutely. But human-friendly? Maybe not so much. What most people wish they could type is something like this. Something simple, direct, intuitive. Just set the delay to 10, you know? Even if it might lose some of that deep, under-the-hood flexibility, it's just so much easier to read and write. And that brings us back to our veteran user, Charles Pendian, who put it perfectly. I think NS3 was developed by brilliant developers for brilliant developers. And that just hits the nail on the head for so many people's experience, right? It feels like the tool assumes you're already an expert programmer before you've even written line 1. But what's fascinating is the core developer, Tom Henderson, he basically agrees. He just phrases it a little differently. He says, think of it less as for brilliant developers and more by and for power users. He's talking about the people deep in the trenches of networking research, people who need that granular control and are willing to climb a steep learning curve to get it. So, Section 5, a tool for power users. This is where it all comes together. The big takeaway here is that we need to stop looking at NS3's design choices as bugs or flaws. They're not. It's all about the underlying philosophy. And that philosophy really boils down to 3 key things. First, it's a library, not an app. You're the builder. Second, it chooses flexibility over standardization, giving you ultimate freedom. And third, it puts power over simplicity. The system is built from the ground up to give experts the absolute control they need, and yeah, that comes with a steep learning curve. Once you get these 3 ideas, everything else about NS3 just clicks into place. So what felt like weaknesses at the beginning, they're not weaknesses at all. They're actually the direct result of its single greatest strength, being a totally uncompromised, insanely powerful framework for expert-level research. That missing run button, the confusing number of tracing options, the complicated code, they're not mistakes. They're features. They're the very things that make NS3 so powerful. And this whole story leaves us with a really big question, one that goes way beyond just NS3. When you're building expert tools, especially for science, what's more important? Should you build for ultimate power, creating an instrument that only a handful of experts can truly master? Or should you prioritize accessibility, making it easier for more people to get started, even if it means sacrificing some of that top-end capability? It's a classic trade-off, really. Power versus accessibility. Where do you think the line should be?